Welcome everybody to this very, very special 5x15 event hosted in collaboration with Groundswell. And thank you all so much for joining us. For the next hour and a half, we have a very special program featuring pioneers from around the world looking at soil health. And I was really pleased to see that it was in fact World Soil Day on Saturday, which I didn't know about, and was very auspicious to realize that we had programmed this at exactly the same time. And I feel very lucky to be working with this incredible group of people here this evening. So Groundswell is an amazing show and a conference. It happens in June next year, and it's on the Cherry Family Farm in Hertfordshire, looking at the issues around regenerative agriculture in the UK and bringing together absolutely cutting edge research and leading thinkers. We know that the conversation is affecting us all right now, and it couldn't really be more topical. And so we're very pleased to have some of the pioneers and leaders in this field joining us from across the world. We've adapted the 5x15 format a little bit, and we've got 4 short talks followed by a short Q&A. And you can put questions in the Q&A box, which you will see at the bottom of your screens, and we will try to get to as many of them as we can towards the end of the session. We are at 5x15 Stories and at Groundswell Ag UK if you want to tweet us as we go along. And first of all tonight, I want to hand over to our amazing friend and partner, Joanna Bowen, who has helped us to curate this program. She is going to tell us a little bit more about Groundswell and about what we can expect this evening. Over to you, Joanna.
Thank you, Daisy. Can you hear me? Yes?
Yep.
Oh, great. Well, I'm so pleased to have a chance to collaborate with the 5x15 to create this program, and it's a real honor to be here. Our family started Groundswell to find different ways to help farmers like ourselves to convert to regenerative agriculture, because it can be a bit nerve-wracking, and to be inspired by great speakers like Gabe and David and learn from each other, sharing experiences and putting best practice into place, and to share experiences in order to find new and better ways to farm, putting the soil first. That's the business. And for us, it was wonderful to discover what an appetite there was out there for change. We didn't have to convince people. There was an open door to meet this creative and vibrant community of innovators. Our annual Groundswell conference is quite literally a growing concern in every sense. And it's a revolution, because this is a revolution. It requires a seismic shift in the philosophy and practice of everything we've done. And the exciting thing about this new community is that it's international. We have speakers and attendees from every continent. So at the conference, you can hear a farmer from Denmark comparing notes with someone from Canada. And there's such a buzz. And worth mentioning, there's a gratifying number of women involved. And keynote speakers, a lot of them are women. So it's exciting that it's actually not what people would consider to be a normal farmery event. When I tell people that we're farming without ploughing, they often ask why no one thought of doing it this way before. And the answer is that to do it on a sort of significant level of size, it's only just become possible because we have the technology now to create the machinery to actually do it. And so we aren't actually a bunch of Luddites trying to turn the clock back, sort of new age dreamers. We're actually using quite cutting edge technology. There's more stuff. Sometimes at the conference they're using drones to squirt weeds on tiny bit rather than spraying whole fields with chemicals. There's such exciting sort of new stuff coming online. And I think that's what I find most inspiring about this. A lot to do with climate change. When we're talking about climate change and the change of our weather and all the problems, we focus on what's wrong and what we're doing wrong. And it's so exciting to be part of a movement where we are capturing vast amounts of carbon from the atmosphere and putting it in the soil just by not ploughing. And it's so easy and so quick, and it's so exciting to be part of something so positive. So I'm so happy to welcome David Montgomery to explain why we urgently need to prioritize this debate about saving our soil, and to hear from Gabe Brown about how driven by necessity again. He did this on his farm and transformed it. And we John and I heard these really inspirational speakers back at a conference in Kansas years ago. And it's a personal honor to have them contribute to this webinar, and also to have Tim talk about the end product of farming, which is food, and the relationship between the soil health and our gut health, and whether food grown in healthy soil is different nutritionally. And then we're going to hear my husband, John, and his brother, Paul Cherry, explain how we changed the practice on our farm in Hertfordshire with a bit of a demonstration to show you the difference it's made. So it looks as though the world is starting to take notice about all this, and more land is under this new farming system and not ploughing. And so without more ado, thank you, Daisy, for having us, and over to you again to open the show.
Thank you very, very much. Okay, so our first speaker this evening is David R Montgomery, author of Growing a Revolution, Bringing Our Soil Back to Life, as well as The Hidden Half of Nature, the Microbial Roots of Life and Health. He is a MacArthur Fellow and he's Professor of Geomorphology at the University of Washington. He studies landscape evolution and the effect of geological processes on ecological systems and human societies. Thank you so much for being part of this, David, and welcome. Over to you.
Great. Well, thank you very much. It's a pleasure to be here talking with you all. I'm going to try and give you a quick tour through 3 books in 15 minutes, which briefly explains sort of what I've been doing on nights and weekends for the last decade or so. I'm a geologist, but I've been writing books about soils and their importance for civilization, both in the past, in the present, and in the future. And the book on the left of the screen now, Dirt, is the one that I started with, and it's the one that looks backwards through history, the one you might expect a geologist to write. And it can be summarized in terms of societies that don't take care of their land don't last. It's a deep dive into history. The middle book that I wrote with my wife, a biologist, Anne Biklé, is the book that looks at the role of microbial life in and around the roots of soil as the key missing thing that we kind of forgot about in 20th century agriculture, but that is fundamental to maintaining soil fertility and productive farming over the long run. And the third book, Growing a Revolution, the most recent one, the one writing which I was fortunate enough to meet Gabe Brown, that looks at the lessons of that first book, takes the science of the second book, and asks the question of whether, looks at regenerative farming as a way to rebuild and repair the damage that we've done over the long haul of agriculture around the world. So why would a geologist like me be very concerned about the state of the world's soils? These 2 factoids on the screen really kind of summarize it. Soil erosion and degradation has caused farmers to abandon some 430 million hectares of arable land around the world. That's the equivalent of about 1/3 of the world's cropland. We'd obviously be able to harvest more if we had that land still in its full native production capacity, but it's not a problem that has been solved. A couple of years back, the UN Global State of the Soil Assessment reported that humanity, the global us, we're losing about 0.3% of our global food production capacity each and every year to ongoing soil erosion and degradation. And 0.3% doesn't sound like a really big number until you play it out over the rest of this century and realize that we're on track with modern conventional agriculture to degrade another 1/3 of the world's land in the balance of this century. It's my contention, and that of many others, that agriculture needs to change this century. The real question is how. And as a geologist, I started looking into that sort of with the backwards lens in writing Dirt, where I looked into the history of agriculture and civilizations around the world and looked at the role of soil degradation and soil loss in the undermining and demise of ancient civilizations. And what I found was a pattern that, I didn't discover. People have written about this since the time of the classical Greek philosopher Plato, for example. But there's a pattern to many civilizations around the world of soil erosion and degradation, helping to undermine them, from Neolithic or Bronze Age Europe, classical Greece, Rome, the southern United States, Central America, and other societies around the world. But if you look back at environmental history textbooks, what you'll often find as the culprit that's identified in the soil erosion that impacted past societies is deforestation. And in researching Dirt, what I came to see is that there was actually a different villain in the tale. It wasn't the axe, but it was the plow that followed. Tillage fundamentally alters the balance between soil production and soil erosion on the lands that we use to grow our food, and that dramatically increases the pace of soil erosion. If you think about natural landscapes that you may know and love, they're clothed with plants, native grasslands, forests. There's not a whole lot of bare earth. A plowed field is a very unnatural situation, and it can result in soil erosion racing ahead of soil production. And if you think of soil as a system that's made from breaking down rocks and merging them with organic matter to create that mix of mineral and biological material that creates fertile soil, if we're losing it, if we're eroding it faster than we're replacing it, then we're quite literally running out of it. And I'm not arguing that we are going to literally run out of dirt on this planet, but we have been undermining the fertility and abundance of the soils that we rely on to grow our food. And I'm going to pick on my own country for a moment, because I generally find that safest to do. And looking back at the historical record, there's lots of examples that I talk about in the dirt book, but I'm going to use the southeast of the United States, ranging from Virginia up here in the upper right-hand corner down to Alabama in the lower left-hand corner. And that gray noodle shows you the magnitude of historical post-colonial soil erosion in what's known as the Piedmont region, the hill country or the upland country of the American Southeast. It was one of the original breadbaskets of the English colonies in North America. And you'll notice from the legend up here in the upper left that there's more than 4 inches and up to even more than 10 inches of topsoil that's been lost in the past couple centuries of tillage-based agriculture across this region. How big a deal is that? If you go back and read the original journals of many of the people farming in this area, they only had 6 to 12 inches of rich black earth over the subsoil to begin with. So if we were able to literally plow off the topsoil across a pretty broad region of our own country in just a couple hundred years using technology that's not all that different than the Romans and the Greeks had, it puts into perspective the idea that with a 1,000-year run at their landscape, they could have completely undermined its productive capacity, and that influenced the course and fate of their societies. What did that do to their soil? This shows you an illustration of 2 soils from within that gray noodle that I just showed you in North Carolina. The one on the right is from a modern conventional tobacco plantation that's been tilled for over a century and fertilized with chemical fertilizers for the last 100+ years. The soil on the left is from literally across the fence, right next door on an area that had been a farm up until the mid-19th century, the mid-1800s. When it was abandoned, there's now trees that are, almost 2 feet in diameter growing on it. And the soil's made from the same rocks in the same climate. The only difference here is how we have treated the land. And you'll notice that one of these looks a lot more fertile than the other. I have yet to meet a farmer who would prefer to be farming the khaki stuff on the right that looks like California beach sand than the stuff on the left, which has a lot of organic matter. And the color difference is due to carbon, the carbon in soil organic matter. Organic matter is roughly 50% carbon. And the degradation of soils around the world is due both to their erosion and to the loss of soil organic matter. How fast is soil eroding from farms around the world? Well, that's something that I researched in writing dirt. What I did is I went to the library for a month, vacuumed up all the data I could find on how fast the world's soil is eroding, and basically came up with 1.5 millimeters as a pretty good global average for how fast conventionally tilled soils are eroding. That means that it takes about 20 years to erode an inch of topsoil. Well, how fast does nature replace it? I also looked into that. A lot slower. It takes her about 500 to 1,000 years to replace that inch of soil that we can lose in decades. Therein lies the problem, and that's essentially the story of what's happened in society after society around the world. Because that net loss of soil, that net loss of 1 millimeter or so a year, implies that you could lose a 0.5 meter to 1 meter thick hill slope soil, 1 to 3 foot thick hill slope soil in less than 1,000 years. And if you look back at the longevity of most agricultural societies around the world, that's approximately their lifespan, with some really important exceptions. And those, of course, are the civilizations that developed along big river floodplains in regions around the world where nature repairs the damage by bringing not only the flood waters, but the silt and the sand that are deposited by those flood waters, which can completely offset the negative effects of the plow. Why? Well, at that millimeter a year rate, it only takes depositing a single grain of sand a year to replace the soil that's lost from typical erosion rates from the plow. So if that's the story of lots past civilizations, it obviously brings up the question of, well, can we turn that around? Do we have to repeat the historical pattern, or can we reverse that at a global scale? That's the question that Anne and I took up in our book, The Hidden Half of Nature. What it describes is how when we bought our house in North Seattle, and we decided to try and make a garden. Anne is a major league gardener. She's a biologist. I call her a plant whisperer. What we'd had was terrible soil. When we pulled the lawn off that our side yard came with, we found out we had soil a lot like that North Carolina tobacco plantation. Khaki colored dirt. There wasn't a single worm in it. There was no visible life forms in the soil. But over about a decade of intensive gardening and composting and mulching, Anne turned our dead soil over there on the left into this stuff on the right that we have now. And I say that Anne did it because she's the master gardener. She's the biological brains behind our collaboration. But the fact that you could turn this dead, lifeless soil into really rich, incredible, life-filled soil and do it in just a decade or so of intensive composting and mulching and care for feeding the soil, the organic matter that it takes to feed the life in the soil was a real revelation in terms of how fast people can rebuild soil fertility. And that got us into looking into the world of the rhizosphere, which is literally Greek for the zone around the roots of a plant. And it's one of the most biologically rich zones on the planet, where there's microbial life that's at the root of the nutrient cycling that builds soil fertility through what we came to call a biological bazaar. And to characterize that quite briefly, if you have a root hair coming down here, the plants are exuding things out of their roots that are called exudates, and they include things like carbohydrates, lipids, fats, proteins. What does that sound like? Food. Plants are pushing food out of their roots, and they don't do it just to be nice to the life in the soil. They're doing it to recruit microbial partners that take those exudates, metabolize them, and eat that food. I mean, it's like putting out free food on a college campus. You put out free pizza, the students show up. When plants put out exudates into the soil, bacteria and fungi show up. They metabolize those exudates, and what do they make out of them? Things that help the plants grow. When we realized that there were microbes in the soil taking plant exudates and turning them into plant growth promoting hormones that then help the plant grow bigger, capture more solar energy so it could put out more exudates, we realized that there was a symbiosis going on in the soil between soil life and the plants. And it turns out that when you look into the parallels between the relationship between the microbiome of a plant around its roots and what's happening in our own bodies, in our own gut, our gut is the equivalent of a rhizosphere turned inside out. And that's what the second half of The Hidden Half of Nature talks about, are the parallels between what the microbes in the soil and in our gut do for the host organism in terms of providing nutrients, providing microbial metabolites that have medicinal effects and that in the support of our immune systems and the defense of both plants and our own bodies. There's great parallels there that Tim may go into further. But when we realized that we could restore the soil in our yard incredibly fast, the way at least a geologist thinks, it obviously brought up the question of, well, it's one thing to do that in a small urban lot in Seattle. Can you do it at scale on farms around the world? And so I started researching what became Growing a Revolution by visiting farmers around the world who had taken khaki soil like this on the left and turned it into richer, dark, more carbon-rich, life-filled earth like the core on the right. And what I found visiting farmers in equatorial Africa, in Central America, and across the United States, and up into Canada, was that the farmers who had adopted the principles of conservation agriculture had really dramatically improved the quality of their soil, rebuilt soil health on time scales that were kind of similar to what Anne did in our yard, and that they had done at full scale on operative, working, profitable farms. And the principles involved, there's three key principles: minimal or no disturbance, and that's where not plowing comes in, so no-till agriculture; maintaining a permanent ground cover, or integrating cover crops so the land was never left bare; and then also integrating a diverse rotation of crops, a diversity of crops. And why are these three things important to work together as a system? That's what all these little microbes are doing up on the screen now, to basically point out that if you were to adopt a style of agriculture that was to cultivate the beneficial life in the soil, the partners in that biological bazaar around the root system of our crops, what you would do is you would stop disturbing them, you would feed them, and you would give them a diverse community to develop relationships within. These three principles also happen to be virtually the opposite of what we have pushed in conventional agriculture for the last century through intensive tillage, intensive agrochemical use, and functional monocultures of growing one or two crops. So this is a new philosophy or way of thinking about agriculture, but these general principles translate to different settings, but the specific practices that the farmers in different parts of the world that I visited used were very different and need to be tailored to the specific setting of the land that they were actually working on. This shows you that what can be done. This is actually a slide from David Brandt's family farm near Carroll, Ohio, where it shows you the soil that he started with back, the equivalent of the soil he started with back in the 1970s, this khaki clay-rich soil. The soil on the left is what he's basically turned his farm into. It's the same soil. It's the Cardington clay soil, but notice the color. The color difference is organic matter, carbon. The structure is different. One of these is far more fertile than the other, and I think you can all guess which that is. The general principles that we identified in writing Growing a Revolution, we tried to summarize as the simple slogan of ditch the plow, cover up, and grow diversity as the recipe for really rebuilding soil health and soil fertility on working farms around the world. And there's another dimension to it that Gabe Brown, who'll be speaking in a minute, that really helped open my eyes to when I visited his farm to interview him for the book. And that is that livestock can be viewed as an accelerant to rebuilding soil fertility. I was trained to think of livestock as something that degraded the land. What Gabe showed me was that there's a different way to graze that can actually help build soil fertility on farmland, and I'll let him tell the story of his own farm, but what I'll do is step back here in the end and synthesize the benefits that I found in interviewing farmers around the world who had adopted these principles with the different methods that they had in different places, were that it resulted in higher farmer profits. It was more profitable to rebuild soil health. Why? Because farmers were able to harvest comparable yields, but spend less on fertilizer, pesticide, and fossil fuels. And that, of course, helps generate benefits for the rest of us in terms of putting more carbon from the atmosphere and into the soil, where it can do us some good. It can help with climate resilience for our crops and results in less off-site pollution, because the best way to prevent nitrate pollution off of a farm is to not have so much being used on farms and escaping those farms. So I think we're at the point today where Joanna mentioned the idea that these principles are sort of a real revolution. I think we're poised for what could be the fifth agricultural revolution, the way I count them, one that's actually prioritized on rebuilding healthy, fertile soils as the foundation for a lasting, sustainable, and more environmentally friendly agriculture. And that's where I will take you to. I think I've probably used my time up, but it's a pleasure to talk to you about all this. And it's an even greater pleasure to be warming you all up for Gabe.
Brilliant. David, that was such a tour de force. You managed to fit 3 books into 15 minutes. That's actually incredible. And what an honor to have you with us. We will come back to you with some questions towards the end. And now I will turn to Gabe Brown, who Dave has just told us about. He is featured in the Netflix documentary, Kiss the Ground, which if you haven't seen it, I do recommend everyone to check it out. He's the author of Dirt to Soil, which tells the astonishing story of his failing farmland and how he brought it back to health, using the soil as the foundation of that transformation. He is a pioneer of the current soil health movement, and he's been named as one of the 25 most influential leaders in agriculture in the USA. And welcome, Gabe. Thank you so much for being with us from North Dakota.
Thank you. It's a pleasure being with you today. Can you see my screen?
Yeah, we can.
Okay. Well, I really appreciate the opportunity to visit with all of you. The Cherries have been mentors of mine for many years, even though I have not had the pleasure yet, and I say yet, of setting foot on their farm. I look forward to doing that someday. What I was asked to do today was simply share with you the story of how my family and I took our 5,000-acre ranch near Bismarck, North Dakota, and that's a picture of North Dakota landscape there, and converted it from one of conventional means into one of regenerated soils. This is a picture of my father-in-law. Him and my mother-in-law started this ranch back in 1956. And my father-in-law loved his tillage. He loved to till. I learned to farm from him. I did not grow up on a farm or ranch. I grew up in the city of Bismarck, but I was fortunate enough to marry into this. And I'll never forget him telling me, Gabe, you'll find out the more you work the soil, the better it is. Well, I have a very inquisitive mind, and I could never understand why that was so, because we would work the soil in the spring to dry it out, and then we'd get the crop seeded. But come July, we were praying for rain. We're a very seasonal type rainfall. We only get about 16 inches of total precipitation here a year. And what I noticed is that over time, that these management practices were actually degrading the resource. This is a photo actually of a field of my neighbors right next to mine, where after he had tilled, we had a sustained windstorm, and the soil actually blew so strong for so many days that it removed all his topsoil, and it was actually laid in the road ditch. And I realized then that my management practices make a difference. Well, in 1994, I decided I had studied enough about no-till, zero-till, that it just made sense to me. And so I sold all my tillage equipment and went 100% zero-till in 1994. So none of the land on my farm has been tilled since 1993. What happened then? I seeded the entire crop zero-till, and in 1995, the day before I was going to start combining, we lost 100% of our crop to hail. And that was pretty devastating, pretty tough to take. Couldn't make all the payments to the bank, but I was scraped together enough to make interest payments. 1996 came along, and we lost 100% of our crop to hail again. So by then, things were getting pretty tough. My wife and I took off farm jobs in order to make some money to support the family. But once again, we couldn't make all of our land payments and our payments to the bank. 1997 came along, and it was a major drought in the area that year, and nobody harvested any crops. So we were now 3 years into no crop income, which pretty devastating. I tell everyone that my neighbors were all waiting for me to fail so they could buy my land, but I was too stubborn to do so. 1998 came along, and that's an actual photo I took that year off of the front yard there. And you can about guess what that cloud led to. We lost 100% of our crop to hail again. So 4 years, 4 natural disasters, 0 crop income. I tell people that was absolutely devastating to go through. I do not wish that on anyone, but it was absolutely the best thing that could have happened to us, because I was forced to make a change. You know, things were really tough. I was 1.5 million US dollars in debt, and the piggy bank was looking pretty skinny by then. And how was I gonna not only raise a young family, but make the payments to the bank and continue to farm? It was at that time that I met a rancher from Alberta, Canada. His name is Don Campbell. And he told me this. He said, Gabe, if you want to make small changes, change the way you do things. But if you want to make major changes, change the way you see things. And that saying absolutely changed my life, because it just resonated with me. I knew that I had to change the way that I looked at farming and ranching. If I was going to survive, pay off my debt, and make my land productive, I needed to see things differently. In order to do that, it takes observation. And now today, I spend the majority of my time traveling around the world, talking to farmers, ranchers, consumers, anyone who will listen about regenerative agriculture. And I tell them, we have lost the power of observation over time. You know, most farmers, they see a weed in the field, they want to spray it. But what is that weed trying to tell you? That weed is nature's way of healing that soil. What's it trying to tell you? If you see pests, what are they trying to tell you? That all takes observation. And we need to, in order for us to be good stewards, we must understand how healthy ecosystems function. And I tell people, I have the good fortune of being on hundreds of different farms and ranches all over the world every year. And I can tell you honestly, I have never, ever been on a single one, including my own, that's not degraded. We are all farming and ranching degraded ecosystems if we were to compare them to what they once were. The good thing, though, is if we hone our observational skills and understand, as David talked about, that nature acts a certain way no matter where we are in this world. And these principles, there's basically 6 of them, are the same anywhere in the world. So nature always acts in context. There is a reason we don't grow bananas in North Dakota. There's a reason you don't grow bananas in England, right? Nature's going to act in context. In nature, as David explained, there's no mechanical and there's limited chemical disturbance. Plants put out chemicals, so we can't say there's no chemical disturbance, but it's very limited compared to what's used in conventional agriculture. Nature always tries to armor the soil, as David said, always tries to put living plants on the soil. And the reason for that is, as he described, those living plant root networks with mycorrhizal fungi transferring water and nutrients to the plants. The plants then share their carbon compounds and they slough those off to feed biology. And it's through biology that nutrients become available. It's really hubris of man to think that we can impose our will on nature. There's thousands and thousands of years in research and development into this natural way, the way of regenerative agriculture. Why don't we work with nature instead of against her? So what that's evolved to on Brown's Ranch, we used to only grow primarily spring wheat and barley. Now we grow a wide array of different cash crops. I've just listed some of them here. Like you, I'm in a cool season environment. And so the majority of our cash crops are going to be cool season, but we do put in a sprinkling of warm season species. That is to add diversity to the crop rotation. Now, what it's evolved further into is we do not grow very often cash crops as monocultures. We grow what we call polyculture cash crops, where we're growing a variety of different cash crops together. The photo that you see in front of you, that's actually cereal rye, spring triticale, forage winter wheat, hairy vetch, and sweet clover all growing together. And now I have developed a barley variety that'll overwinter in our cold environment. And so we've added that to this mixture as well. Here's a spring seeded variety, polyculture cash crop we grow. Oats, barley, peas, and flax. We grow all of these together. And it works very well because we're taking advantages of the synergies of nature. Along with that, we grow diverse cover crops. Even though our growing season, we have approximately only 110 frost-free days every year, we can grow not only cash crops, but we can grow cover crops, either before the cash crop, along with it, or in the case of fall-seeded biennials, after. This is a picture of a diverse warm season cover crop mix. We then use these diverse mixes of cover crops and graze them with different species of livestock. And that's the way that we integrate livestock onto the cropland. And we notice significant improvement to our cropland soils once we started doing that. So we raise grass-fed and grass-finished beef. We finish all of the animals that we are born on our ranch. And just to make you hungry before supper time, I'll show you that we can raise very high quality, nutrient dense proteins in this diverse ecosystem. We have about 300 cow-calf pairs that are out on pasture year-round. Even though we get 75 plus inches of snow a year, we're able to graze our livestock, all with the exception of about 30 to 40 days is all we feed hay. We have a flock of ewes and raise grass-finished lamb. We farrow out hogs during the spring, summer, and fall and raise pastured pork. Those are pastured hogs out on a diverse cover crop mix. We have approximately 1,400 laying hens out on pasture during spring, summer, and fall. During the dead of winter, they are in a hoop house, but they're out free range. As far as they want to travel, they can. We pull around the egg mobiles, and the laying hens add another dimension to the livestock business. There is a difference. Those of you who have seen the movie Kiss the Ground, this is a photo that they shot while they were filming that movie. That's one of our pastured eggs, obviously on your right, and that is a conventionally raised egg on the left. There's a tremendous difference in all these phytonutrients because your health as a consumer is directly related to the health of the soil and the diversity of the biology in that soil. And that shows up in the foods that are grown and raised on that soil. We also have bees, and we produce honey, and we market that raw, unfiltered honey. It's high in nutrient density. So this is a cash flow statement I like to say on our ranch. We start with soil, water, sunlight, all these carbon compounds. We grow cash crop, cover crops, perennials, and those are all the different enterprises that we have on Brown's Ranch. And then everything below the dollar sign is how we convert that solar energy, as David talked about, into dollars. All we're doing is taking sunlight and water and converting it into nutrient-dense products. So on the right there is my neighbor's soil just across the fence. He is no-till, by the way, but not a lot of diversity. The soil on the left is my regenerated cropland. We truly can regenerate soils. Again, my soil's on the shovel, and the neighbor's there is that PED in the foreground. The beautiful thing about it, though, is just as we degraded soils, we can reverse that, as David said, and we can regenerate our soils and build them back. So you will see on this graph in 1993, our farm started out with less than 3 inches of topsoil, approximately 1.7% organic matter. We could only infiltrate 1/2 inch of rainfall per hour. We started to diversify the cash crop rotation and we went no-till. That was a little bump. Then we started the very diverse cover crops in 1997. We noticed a real improvement in the aggregation in our soils and in the amount of carbon. We went to the multi-species covers, integrated with livestock. Every time we added one of these, and I would also like to add in there, 2007 was the last year we used any synthetic fertilizers, pesticides, or fungicides on our farm. When we stopped, especially
Gabe.
Whoops, did I drop off there?
Just for a second, we lost you.
Oh, okay.
You just got 1 minute left.
Yep, okay, and I'm on the last slide. So as we did these steps, we noticed an improvement in the aggregation of our soil, and I guess my slide froze and is not going to, there we go, is going to advance here. So today, where we're at in 2020, our farm averages about 7% organic matter, and we have done dual head infiltrometer tests that show we can now infiltrate over 30 inches of rainfall per hour. So that's the difference there in the soils and what we've done. With that, I will turn it back to you.
Gabe, thank you so much. That is such an inspiring and incredible story. Thank you so much for sharing it with us and being part of this. And we will come back to you in a few minutes for some questions. I know there's lots of questions coming in right now. So our next speaker is Professor Tim Spector. He's author of Spoon-Fed: Why Almost Everything You Have Been Told About Food is Wrong. He's known for many things, not least being the creator of the COVID symptom tracker app, which King's College has been running. And he's a pioneer into research around microbes, genetics, and the gut. He's a professor of genetic epidemiology at King's College London and an honorary consultant physician at Guy's and St Thomas's. And he's here tonight to tell us about the surprising connections between the gut and soil health and our diets. So welcome, Tim. Are you there?
Yes, I'm here. Let's see if I can share my, oops, lost my, you can see this. Okay. Hi, everyone. I hope you can see this. So really very excited to be here, and really also excited about the increasing parallels between what's going on in soil and what's going on in our guts. And often the two communities don't meet and they have slightly different priorities. But this has only really been a field in medicine for the last 10 years. And that's particularly because of the technology that has only become available with genetic sequencing of these microbes. Before that, 99% were unknown. Now only about 30% are unknown in just the last few years. So we have as many microbes in our guts as humans as we have cells in our body, and that's hundreds of trillions of these guys. And 99% of them are beneficial. So everything we were taught at school about microbes in our gut being bad for us are wrong. And the other thing is, as well as it is a giant community of bacteria, archaea, and little viruses that feed off them to keep them in check. And there are also fungi, which are very hard to measure, but less of them, but they're very big, and protists and parasites. And some of these parasites are actually very good for us. I've got one in me called blastocystis, and that's been associated with actually having a smaller stomach fat and better response to food. So some of these are great. And the other thing is that we need to start thinking of our gut microbes as a new organ in our bodies. Basically, this is an organ that is a chemical factory. Each of the trillions of these microbes, and we have about, each of us have about several thousand different species. Each of those has 300 microbial genes, more than we have in our human bodies. Each of those is a chemical factory. And that's really how we need to start thinking about this whole area in terms of chemicals. Because food essentially is a group of chemicals. We've counted at least 26,000 different chemicals in the regular foods we eat. There's probably more of them. And so that's what we're feeding our gut microbes with. And it's this key interaction, just as we saw in the soil, between what we put in our mouths and what is in our guts. And we understand perhaps a bit more about all the functions of the gut microbiome, more than we do in soil, although other things we know less. But if you look at this rather complicated diagram, you can see that it's responsible for all kinds of things. So regulating your sugar levels, your insulin, your inflammation, your risk of heart disease, risk of having dementia, and it's also, it reacts to the environment as well. So whether subtle changes in the acidity of your gut can have huge changes to the microbial species, they are probiotics or not. All these things have an effect, but if you treat it right, it has enormous good effects on your body. So it gives off all these signals to say, you know, I'm fine, my immune system is working well, I'm not overreacting, I'm not giving myself food allergies, everything's cool. And we know that it interacts with the brain. So your microbes produce little chemicals that actually are important for your mood. They can fight depression and will tell you whether you're hungry or you're full. And so increasingly, we're realizing that a huge number of chemicals are produced by microbes that our body can't produce itself. So this is why it is perhaps one of the most important organs in our body, that if you removed it, we couldn't exist. And there's several bits of the body you can do without. Now, the other way to look at it, which has a bit of an analogy with what we've been hearing from David and Gabe, are the fact that when you're sick or you're well, all the studies so far in the last 10 years are all very consistent about what's going on inside your gut microbiome community. And for people who are sick and have any of this list of conditions from obesity, heart disease, allergies, colitis, arthritis, dementia, depression, anxiety, or even autism, have a really denuded gut soil. They have much less species and virtually no diversity, which means they have low diversity of natural chemicals. And if you're healthy, you're lean, your soil is going to be very rich with many more species interacting with each other in the same way as they do in the soil. And this is like the equivalent of, you know, what we've just been seeing in different people's guts. So the really poor soil that's eroded with low levels of fungi and microbes not interacting gives you what you see on the left, like a sort of Nevada backyard. And on the right, you've got more like the English country garden. You know, everything is possible, everything's diverse, it's all interacting. And the analogy is really easy to make once you do that. Now, the other thing we've realized is that as a general rule, low diversity is bad, good diversity is healthy. How can you change between the two? Well, we know that things like poo transplants, fecal transplants can dramatically alter from one to the other. And we also know that if you increase the diversity of what you're giving your microbes, we know that if you have more than 30 plants a week, you're optimizing your number of species you can grow yourself. So in a way, everyone in this model becomes a farmer in your own environment. And as well as having 30 plants, you want to also reduce the number of synthetic chemicals you put into your body, because we react to all these chemicals. Our gut microbes, all these ones listed here, our gut microbes either react badly or they change the way that chemical works. And this is really important for things like antidepressants. Depending on what your microbes are, you can have a good effect or a bad effect. And I've got herbicides in here because things like glyphosate are well known that the companies have shown they don't affect human cells, but they do affect microbial cells and microbial genes. And there's other ones as well, like artificial sweeteners, which are made from paraffin and other synthetics. Many things you find in ultra-processed foods reduce the diversity of your gut microbes. So the other thing to note is that probably just like two farms, no two people are the same microbially. And although we share 99.5% of our DNA, we only share about 25% of our gut microbes, and even identical twins are actually quite different. So give me a sample of your gut microbes and I can tell much more about you than I can from your DNA. And this uniqueness is very important because it means that's why we react to foods so differently and so uniquely. And just as an example, a few years ago of how important these microbes are, we found that when we looked at 1,000 twins, the skinnier of the twins always had more of these microbes. And this is generally the case, that the healthy people have a rich variety of microbes that produce different chemicals. When we stuck those in mice, you could keep them skinny, whatever you fed them. And so this is the sort of the hope that we can start to understand these microbes to help human health. A couple of years ago, I went to visit a hunter-gatherer tribe in Tanzania and ate their diet for 4 days to discover why these guys have more microbes than anyone else on the planet. They have the best diversity. And we've lost that diversity just as we've lost in soil. And the key here is that these guys have been hunter-gatherers for 10,000, 20,000 years, and they have never had antibiotics, they've never had highly processed foods, and they have an amazing diversity of diet. They eat everything they see around them, and they have 4 times as much fiber as we do. I stayed with them for eating their food for about 4 days, and my diversity went up about 20%, but as soon as I got on the plane home, things went back to normal. Airplane food reduced me back to where I was. So, but this gives you an idea of what we can achieve if you did this longer. Some of that is lifestyle, some of it is the food. Obviously, nobody's washing their hands there, and they've got lots of healthy dirt to roll around in. So microbes need fiber to produce these short-chain fatty acids. So this is, in a way, the fertilizer we need to give ourselves. And when we don't have it, you actually lose the integrity of your gut lining. And that's what happened when I fed my son a McDonald's diet for 10 days. He lost 40% of his gut microbes in that time. And I thought I could easily get that back. And so I sent him some fruit and veg parcels. Unfortunately, 3 years later, he was still on the lowest 2% for his age. And it's only now, about 5 years on, that we've got him back in the normal range. So if you denude an area for too long, you may not have the microbes there to recover. And just to finally remember high polyphenol foods. We didn't really understand this concept of high polyphenols. We thought they were just antioxidants. We now know they're actually rocket fuel for your gut microbes. So another reason, if you're choosing what to eat, as well as diversity, go for high polyphenol foods. And they, some of you might be pleased to know, include dark chocolate and red wine, which are all good for you, as well as coffee, nuts, olive oil, and berries. All of these are really good for you, and ignore all the other rubbish about fats being bad for you or worrying about calories. So if you look after your gut microbes, they'll look after you. That's essentially what we've got. And the other thing to say is fermented foods are also a really good thing to eat. A bit like a probiotic every day. It's just giving yourself an extra microbes as a small shot, however you can do it. So the message here is we're all unique. Microbes are key to our health and our unique response to food. Improve your gut diversity with plants diversity, avoid ultra-processed foods. And in future, everyone is going to be needing more personalized approaches to nutrition. And my books, Diet Myth, are really around the gut microbiome, and Spoon-Fed is about personalizing nutrition and the evil influence of the food companies on manipulating everything we eat and distracting us from what is healthy. And the final word is that there's been some recent papers showing very clearly that what's good for your gut is also good for the planet. And so there's a clear link between everything I'm talking about here and being good for our planet. So if you keep your gut in mind, you can't go far wrong. So on that note, I'll hand you back and look forward to some interesting questions.
Thank you so much, Tim. It's always such an honor to work with you. I know you're one of the busiest people in the whole country, so thank you very, very much for finding time to be with us. And we will come back to you in about 15 minutes. Before that, we are going to introduce John and Paul Cherry, who are the founders of Groundswell, who are joining us from their farm in Hertfordshire, and they're going to talk about the regenerative systems and the benefits in the UK. You might have seen John's piece, which was in the FT this weekend, talking about the end of EU subsidies and what the potential might be. So we're very, very honoured to be working with you, and over to you, John and Paul. Welcome.
Thank you, Daisy. Yes, oh gosh, it's also fascinating. I know this is a very timely talk, this in the UK, because we're, for the first time since the last war, pretty much, the UK's got a chance to make its own agriculture policy. And it's just so important to get this right. And the exciting thing is we've got a model of how good the future could be. Presumably, we want farmers to grow nutritious and tasty food without doing too much damage. As we've heard, we can do that and actually make the world a whole lot better at the same time.
I think this has got a good chance to just bring on our little demonstration, which is
a blue peas moment.
Yes, this is one of the most fundamental things about soil and about no-till. In my hand, I've got a bit of ploughed soil, and John over there has got a bit of no-till soil. So that's 10 years no-till. This has been ploughed, well, ever since I can remember. And they're just the other side of the hedge, neighbour, ours. We're going to put this in a jug of water, and I'll just hold that card behind. And watch very carefully, and you'll see what happens. So in they go, and hopefully you can see that the ploughed soil is collapsing. It's got very little stability, and it is just falling apart. So imagine if this is in the field, this is a rainstorm, this soil is breaking down, filling the drains, running down the ditch, and silting up rivers further downstream. Whereas our soil is carbon rich, it's holding on to itself, it's doing everything that a good soil should do, and it's also more fertile. We'll come on to all these points later, but this is the most fundamental thing. Also, just look how cloudy hopefully you can see how cloudy this this water is. The silt is just we're losing the silt all the time. So we're on this sort of drive ever since the war. We've been on this drive to produce cheap food, but by whatever means. But it comes at a price, and the price is erosion. And you're seeing erosion before your very eyes here. This is topsoil being damaged. It's taking these little particles away, complete, I may say, with the fertilizer and the chemical residues which pollute the water supply downstream. This is happening so much more dramatically probably in the Great Plains in America, where they've lost hundreds of millions of tons and millions of acres of topsoil. It goes down the Mississippi and into the Gulf of Mexico, and they can see, they've seen dust storms in our lifetimes, and they've seen catastrophic loss of topsoil. It's happening in the UK, but it's just happening much more. Mm-hmm.
That's right.
That's right. It's just happening in the UK, but it's happening much more gradually. We don't have we don't have the dramatic weather patterns that we have over in the States, but the point is it's still happening. If you, next time you look at a picture of the Houses of Parliament, look at the colour of the river in front of it. That river is brown. It's always brown. Why is it brown? That brown is topsoil, and the most valuable asset on the planet, And once it's gone down the river, we never get it back.
The other thing that's reduced by degrading soil is its ability to absorb water. Gabe says his soils now can absorb 30 inches of rain in an hour. That's quite a good rainstorm. And it's oh, hello. And ours is nothing like there. And but we're getting there. This is 10 years in, and already it's got an inherent structure. And one of the reasons, as we've said, as has been said earlier, is the carbon that the plants have taken from the atmosphere, and they've sequestrated it in the soil. And so it's carbon capture. It gives the soil a wonderful sponge-like capacity, so it can absorb the rainwater, hold it there for dry periods, and keep the plants growing. It's the best fertilizer, water in a dry time. And so you want it in your soil.
We're also losing fertility in these soils. There's obviously what's going away with the soil is fertility. So what do? We end up using more and more fertilizer, needing to replace all the goodness that is in that soil with more fertilizer to get the same yield from the same harvest every year.
And the other crucial thing to mention with fertilizer is the energy involved in making it. So the nitrogen, the air we breathe is 80% nitrogen, but in order to make it into a usable form for plants on an industrial scale, you need to use the Haber-Bosch process, which uses 8 tons of natural gas to produce 1 ton of fertilizer. And how much is a ton of fertilizer? Well, on this farm, we'll use at least 150 tons a year. We're using less and less every year, but it's a massive energy draw, which doesn't normally hit the balance sheets because it happens somewhere else. We just buy fertilizer and don't ignore the energy cost of it. And then, of course, when you put the fertilizer on the ground in the sunshine, a lot of it is released as nitrous oxide. And these two things, fertilizer impact on global greenhouse gas emissions is 2.5% of all total greenhouse gas emissions from any source. It's a massive factor in climate change.
I'm not going to put up, hopefully, going to put up 5 slides showing the 5 principles of regenerative agriculture. These pictures are all taken on our farm in North Hertfordshire. So here we see diversity. Top left, oilseed rape. Top right, a field of oats. Bottom left, a field of beans. And bottom right, a lovely mixture of grasses and sainfoin. Obviously, we rotate our crops. But what the soil really loves, as you heard from the previous speakers, is the diversity of roots, different roots and different activities in the soil. Everything, all the soil microbes can engage with that. This picture is a new crop growing through the residue of last year's crop, and indeed a cover crop. You'll hear about cover crops. Cover crops are just crops that we don't harvest, so just there to cover the soil. So you can see the little green rows popping up through undisturbed soil, but with the dying residue of last year's crop there. And the next slide is our seed drill running through. That just shows what happens when the seed drill runs. It's a row of discs popping seed into the soil, but crucially, the disc just cuts the soil, and then those wheels, not big wheels, the little wheels, you can see them pushing the soil back down. And it's quite hard to see where the drill has been. The little bit on the right is undrilled, and the bit behind the drill obviously is drilled. But the important thing about this is to minimize soil disturbance. So if you're an earthworm, if you're a soil microbe, you don't want to be disturbed. It's quite a fundamental point. So we don't disturb the soil. we're maintaining living roots. We're looking straight down into a cover crop there. I can see linseed, sandpoint, clovers, all sorts of goodies going on there. That is just feeding the soil. Most of what I can see there are legumes. Legumes, as I'm sure we all know, get nitrogen out of the atmosphere totally for free. They give it, they pull that, the microbes in the roots of the legume get hold of nitrogen out of the atmosphere and turn it into nitrate and give it to the soil, give it to all the living creatures in the soil, and crucially make the crops grow. So that's all for nothing. So maintaining living roots, and imagine if you're an earthworm living under that one, you're a pretty happy worm. The soil doesn't, if you've got all that cover, the soil doesn't dry out in summer, and it doesn't get so packed down by winter rains or deep by snow, if we ever get any. But so maintaining living roots is exactly what we've heard about from previous speakers, the transfer of all the energy from the sun into the roots and out into the soil. And the last slide is
livestock integration. Well, I mean, we've gone for 5 principles. I noticed Dave had 3 and Gabe had 6, so we thought we'd come sort of in the middle with 5. But actually, I think, well, anyway, these are our cows. They're a different colour to Gabe's, but are eating a similar kind of mix of lots of different things. We've planted 19 species, I think, in this herbal lay. So we put these lays down for 3 or 4 years and graze them, and it ticks all the boxes of our 5 principles of having living roots in the ground, keeping the ground covered, diversity, animal impact, everything. It's a wonderful thing, and it makes the most delicious meat. We're very pleased to be working with the Pasture Fed Livestock Association, who are trying to promote this business of having animals 100% pasture fed. It's so much more healthy for the animals. They're, after all, going to be food, and we want to be eating healthy food, whether it's animal, wheat, cauliflower, or one of Gabe's bananas. It's important to have healthy food, whoever you are.
There's probably a good moment to just mention methane is obviously such a topic with particularly with cattle. Would you like to just?
Yeah, methane. I mean, these cows, it has to be said, are burping methane. But the wonderful thing about having them on pastures is that you get methane-eating bacteria on the pastures, and they're stimulated by the cattle who grasping the grass with their mouths, and that stimulates them to jump up and eat the methane that's about. And also you to get the whole thing's turning into a science lesson, but you'll get a lot of water vapor coming up out of pastures, and in sunlight, a lot of the water is split into hydroxyl radicals, which occur at 100 times the amount of methane in the atmosphere above pastures. And basically, these hydroxyl radicals will eat the methane that comes from cows grazed at pasture. So the cows aren't the problem, it's the how. It's not the cow, it's the how, as the saying goes. And it's how cows are raised. And this is a fantastic way of restoring health to your farmland and producing incredibly good food and not creating a problem with methane.
So those are the that's our slides. Can we just go down?
What's the time?
Yeah, we've got to crack on a bit.
Are we ready for some questions, John?
Oh, right. Okay. Yeah.
Are we? We've got 8.
Yeah, I think everything we were going to say has been said before, so that we don't want to bore everyone by repeating it.
But thank you very much.
Thank you very much.
Well, you can finish if there's something you want to finish with. But Joanna's been digging in the question and answer box to dig out some of the best questions. We've got lots and lots, so I'll hand over to her.
Okay, thank you, David. One of the, oh, hang on, sorry. We've got feedback from the other one. One of the first questions that came, a lot of people are asking, is to Gabe, and they want to know how you harvest your crops, cash crops, when you've got them all together. How do you split them for harvest, Gabe? I don't know. I remember there are about 20 people have asked that, so I thought I'd better get that in first.
Yep, that's an excellent question. And some of those
hang on, you're muted. You've got to unmute.
No, I am unmuted. I am unmuted.
Yeah, I can hear you, Gabe.
We can't hear you.
Okay.
You can.
Yeah. David can hear me, right?
All right.
Yeah. Okay. Yeah, I was unmuted. So we harvest them all together. We grow, the species we grow together have approximately the same maturities. So they're able to be harvested together. We combine them together. Now, if we do want to separate them, then they need to be of different seed sizes and shapes. So for instance, we can grow a oat, pea, and like canola mix, and that mix is easily separated because there's 3 different seed sizes. So they have to have different seed size and shapes. When I'm doing my very diverse mixes like that fall seeded biennial, the winter wheat, winter triticale, and cereal rye, that we would not separate. We use those in hog rations or as cover crops. We leave them as a blend.
Okay, thank you very much. And then the other recurring question that lots of people have asked is, why isn't this more recognized? Which is my reaction when I first heard all this, so I understand this question. Why is there not more political goodwill? And why, for example, isn't Countryfile putting it on television, which I do remember when we actually approached Countryfile some years ago, they couldn't have been less interested and honestly treated us as though we were slightly in a cult or something and a little bit kind of way out there. So, but why? Why isn't this more general? I think this is a political question, really, for anybody who wants to come in on that. Dave, you do.
I was gonna say, in part, it's that the point that Gabe made about, if you want to make big change, you have to think about something differently. That's at the heart of this. We've been, the conventional agricultural world has been teaching very different things for 100 years. So there's an awful lot of conventional wisdom, which is grounded on science from the 1950s, frankly. We've learned a lot, particularly in the realm of microbial ecology since then. And what these new methods are trying to do are trying to update that understanding, and the ability to actually merge the no-till and the cover crops and the diversity is actually pretty recent. Cover crop, crop rotations and are not new, but being able to do it with no-till is very new. These are new technologies have allowed us to do that. So it's a new way of thinking. It's a new set of technologies, and there hasn't been a whole lot of academic study of the full system of all 3 principles. Academics tend to like to break things into small problems and work on no-till or cover crops or diversity. But from what I learned from interviewing farmers like Gabe is it's the combination that really produces the profound results in a quick time. That's harder to study, and there's fewer case studies. That's why I went around to interview people like Gabe, because they are case studies. That's data, that's science. It's an experiment that's been done. And we need more people to be looking at some of those early adopters and the success they've had to try and communicate that more broadly. So I'll let others weigh in on that.
I would just briefly add to that, realize that, and I'm speaking in the United States or countries that are where agriculture is heavily subsidized, that that goes against the grain. And so governments like those in the United States want a cheap food policy. Cheap food does not necessarily mean nutrient dense food. In fact, it doesn't. It's just the opposite. But you have the Fertilizer Institute, the Grain Growers Association, the implement manufacturers, all of those are lobbying against regenerative agriculture. And the other thing is, who's going to pay for the science for the universities to do the science of regenerative agriculture? That's all funded by big business. Big business is not going to pay for that. So that adds to just what David said as the reasons that it's not more widely adopted, but it's coming.
Okay, and does anybody want to add to that? I think it's a political question too, because it is to do with vested interests, and vested interests tend to be advising governments. I mean, the experts who come on board, and actually farmers, because most agronomists are given grants by seed companies, by agrochemical companies. And so you have got all of that it sounds cynical to say, but it just takes time to change the view as well that you were talking about, to change the way of seeing it for the vested interest groups too, because they too could be making money out of this, presumably. How would regenerative agriculture, this comes from somebody, feed the world? I think there's this perception that if we do it this way, that somehow there won't be enough yield, the yields will fall.
That's a false perception. I mean, one of the things that was very clear from farmers all over the world that I interviewed for this is that after they restored fertility to their land, their yields went up, not down. So the idea that regenerative methods would not produce, comparable if not higher yields is just wrong. But there can be a transition period, right? If you take a field that's been degraded, you're not going to get the same yield out of it the first year or two that you start with these methods, although there are ways to try and accelerate that process and to streamline it. And the most obvious one is to learn from the examples of people who've already done it successfully, and pray that you don't get hailed out 4 years in a row.
Very good, thank you. Okay, so here's somebody saying the UK has a wide range of soil types, both in terms of texture and natural drainage. Are there certain soil types that present a greater challenge to farmers seeking to implement regenerative agriculture? Do you think that's true in England?
Certainly a lot easier on lighter soil. Some of our heavier ground, there's a whole raft of things that you have to do to make it work, and it's Gabe's point about changing how you see the world is so crucial, I think. But it's easier on lighter ground because it works so much better because apart from else, the extra carbon in the soil will give you all that extra water, which you're missing. Light land will, in dry weather, it'll give up really quickly. But if you've got that soil sponge of the carbon in there, it'll work better. And you can get on, exactly when conditions are right. But it works on it works on every type of soil type. I mean, you're mimicking nature, and nature's worked out how to grow stuff everywhere. So
exactly, that's exactly it. Right now, we're consulting on over 10 million hectares in the United States, and we have yet to be stumped. There's nowhere. You give me that challenge, I'll get it to work.
Okay, I don't know how many more we've got time for, Daisy. What do you say?
5 minutes. Is Tim still with us?
Yes, I think. Is Tim here? I couldn't see his face.
He's still here.
There are a couple of questions.
I am here. I've been answering some of them in the chat. So.
Oh, good.
Very busy.
Oh, so you've seen.
Well, you've been talking farming and stuff, so I've been talking about that.
You saw the one about the red wine. A lot of people are gripped to see that the red wine is actually good. They're asking how come that's so.
Yeah, so well, there's been this story about red wine for years that it somehow protected the French from heart disease, and they got 3 times less than the Brits did, and all the epidemiology still shows that red wine in small amounts, 1 to 2 glasses a day, actually protects against heart disease. So despite what you were told, because governments don't want that story to go around, because it's not, has obviously other people will overdo the medicine very commonly. But it appears the reason is not the alcohol, but it's the actual polyphenols, these defense chemicals in the grape skin that are the antioxidants, that there's over 120 different polyphenols just in the grape itself. And once you ferment any food, you increase the number of chemicals sort of 5-fold. And that's why when you're fermenting anything, you get many more chemicals. So it's this huge diversity of defense chemicals that, as well as being defensive for the plant, actually feed the microbes. So it's feeding our own microbes, and that's how we think it works. That they then have anti-inflammatory chemicals, help our immune system, and magically make us live a little bit longer. But you can overdo a good thing, though, as with most things. So
thank you for that. Fabulous.
And cider is the other thing as well. So people, for the reason the apple skins are also good. So if it's traditional cider, that's got very large numbers of polyphenols as well. And white wine, of course, doesn't quite make it because the skin is taken out after a few days and doesn't last as long. So not as many polyphenols. So it all comes down to understanding the chemistry of food.
Excellent. Now, the final question, I think, is it says, Gabe or David, I struggle to see how we could make this system work on our farm without glyphosate to terminate the previous crop. Can you explain your attitude to glyphosate and how it's changing? Maybe Gabe.
Sure. So we have not used glyphosate on our farm in many, many years. And the way you do it is you just observe and read. Now, we get winter here. I mean, you know, we can freeze 9 months out of the year. And I use that as my benefit. That terminates our cover crops. And then we'll graze those cover crops with our livestock during the winter. And then that residue, as the cherries showed, we're seeding into that residue. And that residue is what inhibits the weeds from germinating that.
Okay,
so
but what about,
you work with
nature. In our more temperate climate, because this person is writing from the UK.
Yeah. Well,
you can't rely any longer on hard frost.
Right. So then you use a crop roller, and that's what they're doing in the southern U.S. You know, warmer areas. You just have to plant a cover crop that can get to that stage and thesis where rolling will terminate it. So that goes back. That's why we added the principle of context. You have to farm or ranch in your context.
Well, as a matter of fact, one of the things that's so heartening about running the Groundswell conference is having all these people come together and it be such a kind of way of finding out stuff, because there is no guidance. Yep. Conventional farmers have agronomists who say, go into that field and squirt this chemical on and this much, and they just haven't got to think at all. But suddenly, if you're thinking, you need help, you need people to ask, you need advisors. And that seems to be hopefully something that's coming on more and more, is that we're able to help each other.
Mm-hmm. And that's exactly right. The other thing, though, farmers cannot be afraid of failure. You need to make your failures learning experiences. We try and fail at several things every year. If we don't fail at things, we're not trying hard enough. So I can't tell you which cover crops will grow on your specific soils, but I know some will. And that's where the power of observation and trying experimentation comes in. Every farmer needs to experiment with different things and learn. That's one of the joys of regenerative agriculture, is you're going to learn something new every day.
Thank you. And over to you, Daisy, to finish off.
Thank you all so much for being part of our amazing session this evening. Thank you very, very much to Groundswell, who brought together this program. I hope that we'll all be with you in June 2021 for the festival, for the conference, and that we'll be sharing more ideas together. It has been such an honor, through the power of Zoom, to be able to connect with you all. And I know that we've had more than 800 people Zooming in. We've had hundreds of questions, which Tim has been amazingly fielding as well, and it has just been a real joy. So thank you very much to the whole team at Groundswell, Joanna, John, Paul, Alex, and everyone else there, and to our amazing speakers, David Montgomery, Gabe Brown, Tim Spector, John Cherry, and Paul Cherry. And we hope to see you soon at 5 by 15. Good night. Thank you.